Hello everyone. As you all know, my name is Sanskriti and I am currently pursuing my BE degree from SVC Bangalore. Today I am again back with one more topic in mathematics, that is simple sampling of attributes. So let's get into our topic. First is we are going to discuss about the definition. What does it mean? So a simple random sample is a randomly selected subset of a population. In this sampling method, each member of the population has an exactly equal chance of being selected. This method is most straightforward of all the probability sampling methods. Since it only involves a single random selection and requires little advanced knowledge about the population, because of uses randomization, any research performed on this sample should have high internal and external validity and be at the lower risk for research bias like sample bias and select bias. So this is a diagram. So first one is definition of population. Second is random select sample, then collect data from the sample. So I'm going to explain it how. This probability distribution is simple random sampling is used to make statistical inference about the population. It helps ensure high internal validity. Randomization is the best method to reduce impact of potential confounding variable. So in addition, with a large enough sample size, a simple random sample has high external validity too. So it represents the characteristic of larger population. However, simple random sampling can be challenging to implement in practice. To use this, there are some prerequisites. There are three prerequisites. You have to complete list of every member of population. You can contact or access each member of the population if they are selected. You have the time and resource to collect data from the necessary sample size. Simple random sampling works best if you have a lot of time and resources to conduct your study, or if you're studying a limited population that can easily be sampled. Next slide is going to tell you about some cases. Three cases are listed below. Those are systematic sampling, stratified sampling, and cluster sampling. So let's get into this. First one is it involves choosing your sample based on the regular interval rather than a fully random selection. It can also be used when you don't have a complete list of the population. Stratified sampling is appropriate when you want to ensure that specific characteristics are proportionally represented in sample. You split your population into strata. For example, divide by gender or race, and then randomly select from each of these subgroups. Cluster sampling is appropriate when you are unable to sample from the entire population. You divide the sample into clusters that approximately reflects the whole population and then choose your sample from a random selection of these clusters. So our next slide is how to perform simple random sampling. There are four key steps to select a simple random sample. Step one is define the population. Start by deciding on the population that you want to study. It's important to ensure that you have access to every individual member of the population. So that can collect data from all those who are selected from the sample. For example, population. In the American Community Survey, the population of all 120 million households who live in the United States, including the household made up of citizens and non-citizen alike. Step 2. Decide on the sample size. Next, you need to decide how large your sample size will be. Although large samples provide more statistical certainty, they also cost more and require far more work. There are several potential ways to decide upon the size of the sample, but one of the simplest involves using formula which your desired confidence interval and confidence level estimate size of population you are working with, and the standard derivation of whatever you want to measure in your population. The most common confidence interval and level used are 0.05 and 0.09. These two we are using frequently. So respectively, since you may not know the standard deviation of the population you are studying. So one example we are taking, that is sample size. The ACS follows 3.5 million household each year. This is a small fraction of overall population of 128 million households, but it is large enough sample size to gather detailed data on all geographical region and demographical groups of United States, including those usually unrepresented in surveys. Step 3. Now we are moving towards our step 3, random select your sample. This can be done in one or two ways, the lottery or random number method. In the lottery method, you choose the sample at random by drawing from the hat or by using a computer program that will simulate the same action. In the random number method, you assign every individual a number by using a random number generator or random number table. You can randomly pick the subset of population. You can also use the random number fraction RAND in Microsoft Excel or to generate the random numbers. Example is random selection. The Census Bureau randomly selects addresses of 2,95,000 households monthly or 3.5 million per year. Each address has approximately a 1 in 480 chance of being selected. Step 4. Collect data from your sample. Finally, you should collect data from your sample to ensure the validity of your findings. You need to make sure every individual selected actually participates in your study. If some drop out or do not participate for a reason associated with the question that you are studying, this could bias your findings. Example, if young participants are systematically less likely to participate in the study, your finding might not be valid due to the underrepresentation of this group. So, thank you for today. This is what I was going to convey in this PPT. So, do like and subscribe my channel. Thank you.